Tak. Okay, so in English. Welcome to the last JUG session of this year. Today we have Jan Lahoda talking about the future of Java. So before we start, as usual, we have some food and drinks in A321 at the end of the hall. So after the session, please help yourselves. Floor is yours.
Yeah, thank you, thank you. So, as was said, I'm Lahoda, and I would like today to talk about, let's say, new things in Java. You will see what span I intend to cover. And I work at Oracle in Prague, and I work on the Java C compiler inside JDK, which is compiling the Java source code to the class files. But I'm, of course, only one member of the team working on that. So, as you probably know, but I will repeat that. Long time ago, JDK releases were very long, and there were some defining features, and the release was quite often delayed because of the defining features were not done, and the release was unpredictable and so on, which was inconvenient for many people. So at one point, basically, between JDK 9 and JDK 10, this was changed, and now the JDK is released every 6 months in September and in March. The first such release was JDK 10, and some of these releases are long-term support releases, which means that some companies want to provide support for them longer than the 6 months or so. The advantage of this approach is that it's possible to add any kind of feature to any of these releases. So we can have a new language feature in principle every 6 months or in any of these small releases. But at the same time, it's really difficult to do big changes or like huge language change in 6 months. So some of these features are added as incubating, that is mostly for library features, or as preview, which can be any feature. And after the experience with the feature is good enough, it's finalized in some release. And we are using some process that is based on YAPS, which is JDK enhancement proposal. And just to know where we are in the releases, JDK 23 was released the past September, and JDK 24 is scheduled to be released in March next year. And today, this is not my last slide, but almost. Today, I would like to talk mostly about some features that I find interesting, mostly from JDK 10 to JDK 24 and some in the future. And I would like to stress out that JDK 24 is basically feature complete, but it still may change before the release. The features may change, so what I say about JDK 24 may not be final. And of course, any preview feature or any future feature that I will be talking about may change in any way or may be dropped. And you may know, like, we actually had a preview feature, language preview feature called string templates that was dropped from JDK 23 because there some problems with the feature were found, and there is like, let's say, redesign or reconsideration for the feature. So what I have, what I have is mostly a demo or showcase of the features. But there is one thing that I wanted to show you, and that is up until JDK 9, the releases were huge. Up until JDK 9, small changes, some release changes. And it said that JDK 9 was the last huge release. So yes and no. In JDK 23 there were 12 YAPs, which are these. In JDK 24 there are 24, which I think is pretty impressive for a release that was done in 6 months. So these are things that are currently in JDK 24. And no, here. And okay. And now I would like to show you some things that are new or relatively new in Java that you may or may not know. So in first thing is a feature that is not really a JVM feature, library feature, or language feature. It's a feature.
Hi, welcome back to Understanding Gradle.
As such. And since JDK 11, there's one question I have. What version of JDK do you use? So who uses JDK that is newer than JDK 21? Okay, JDK 21. Okay, 17. Okay, that's good. So you may know, yeah, I subtracted those that. So you may or may not know, but since JDK 11, you don't need to compile simple Java files that are just one single Java file to run it. I can do this, and let me do it very specifically on 11 here. And if I will do it on 11, I can run a Java file like this, and like the launcher will compile the source for me and run it. And that was good, but it does not, it really requires that the code is inside one Java file. So if I have like this, I have this class greeter that can produce hello world. And if I want to use it from the say hello, I can, of course, somehow. And I can do this and this. But like on 11, I cannot run it because it does not have any source path, any way to find files in the neighborhood. But since JDK 22, there is, there is a new feature that is called multi-file source code launcher, which basically, given one source code, it will find some kind of source root and will resolve any classes that you need relative to this source root. And it also allows to declare modules if you like Java modules if you need. So I think that this feature is pretty good. And related to this, like I will be moving from features that existed for some time to features that are relatively new to features that will be in the future, and I will try to do it like in features that relate to each other at least a little bit. And one feature that a little bit relates to launching Java programs are, now it's called simple source file programs. And that is basically, you are probably Java developer, so it doesn't apply to that much, but imagine that you are a novice programmer that never programmed in any language, let's say, and definitely not in Java. And you want to write hello world. So what you will see is, what you will need to write is this. So, and now you can ask questions like, what is class, what is public, what is static, what are these like 3 dots here? Why do I need to type 3 dots here, or like angle brackets? And these are complex questions. And then, of course, you may also ask, what is system out? Which, like, for us, it's probably not that big problem, but for a novice user, it may be a problem. So there is an effort to make like starting learning with Java from very scratch easier. And this the feature was changing names a little bit. You have the names here. Right now it's simple source files because it's not only for novices. You can use it as well. If you want just some very simple script, you can use the feature as well. So it's generally used for not only for novices. but the feature is that I can skip the like enclosing class, and the compiler will generate this class for me. That is like one part of the feature. There is still class, of course, and if you compile this, you will get a class file as the class. You just don't need to spell it in the source code. And then there is a Java launcher feature that you don't need to write this public static. So first, the main method doesn't need to be public, and if it's not static, the launcher will create an instance of the class and run the main method on the instance. And you don't need to type the args here if you don't want to, if you don't need the args. So you can do something like this, which is nicer, I would hope. There is also a part of this feature that there is a new class called IO, which contains a few methods, okay, or not, which contains a few methods like print and readline, and that you can use, and there are discussions about how exactly this class should look like and where it should reside and so on. So let's not dive into the IO class right now. And this, in these simple source files, again, like for novice users and maybe even for you, for some simple scripts, you, I don't know, maybe want to use a list. And you don't want to learn what is import, right, at the very beginning. So, okay, let's see if this will work. Sure, it doesn't, of course. And so inside these simple source files, everything from Java base, every accessible public type from the Java base is imported. And that gets into like adjacent language feature that is module imports. You can type this, and it means please import every type, every accessible type from this module, from exported packages from this module to this compilation unit. So for Java base, you get Java util, you even get the new class for API if you're on 24 and so on. And this import is implicit for the simple source files where you don't use the enclosing class. Yeah, and I should probably say that you can add additional methods here in the simple source files. You can use methods, you can use fields, you can use nested classes if you want to. It's okay. You can't use constructors. You can't define a constructor. So this may be nice. And now I would like to switch to language features, if you are okay with that. And let's start with something that exists in Java for a long time, but there may be some things that you don't know. And that is local variable type inference, also called var. I think everyone calls it var. And it basically means that if you say var name, then the compiler will infer the type for you. The variable still has a type. The type will be just inferred for you by the compiler. And it exists since JDK 10, so it's an old feature. But let me show some potentially interesting things. And there are two that I would like to show. And one of them is, consider this method, this get method. It returns something that is both hersequence and runnable at the same time. Every instance it returns, it will be hersequence and runnable. And if I just call the method like this, I can call both the hersequence and runnable methods on the result. But if I put it into a variable and I type the type into the source code, I am losing one of these types, right? I will either use hersequence or runnable. But if the compiler will infer the type for me, the infer type is not typed in the source code, so it's not limited like by things that I can type. So the compiler will actually infer that is both hersequence and runnable and it will be actually her sequence and runnable the type, and I can call methods from both of these interfaces. And it goes one step further. If the inferred type is an anonymous class, then like the type will be actually the anonymous class, and you can call methods on that are specific to the anonymous class, which is interesting, I think. Okay, then yeah. Those that use 17 know that you can probably use text blocks, which is multi-line string literals, which are like which begin with 3 double quotes, maybe some white spaces and a new line. The good thing is that you don't need to escape double quotes. The new lines are normalized, and the white space here, common white space here, is elided by the compiler. So it's very useful for me for tests. Like I write a lot of tests where I need code snippets that are fed into the compiler. This is very good. And I said that we used to have a feature called string templates, which has been removed for now, which shows that and it was a preview feature, and it shows that preview features can actually be removed. And then this might have been the first language feature done in the new model, and this feature is switch expressions. It's called switch expressions, but it's actually like 3 different smaller features, and 2 of them apply also to switch statements. So it's not like that you could use this only in switch expressions. There are switch statements, switch expressions, and most of the features between them most of the functionality is shared between them. The differences are relatively small between them. And so, like the 3 sub-features for switch expressions are that you can have multiple case labels, like here. It's like similar as if you type case J, case match, and so on. Then, probably more importantly, you can use this arrow, and the arrow means that there is no false route to the next case. You don't need to break. It will just execute what's after the arrow, no breaks needed, no false route, most likely less bugs. And you can only use expressions here, blocks and throw after the arrow, which also has some nice properties. And as I said, these 2 work for switch statements. You can use arrows in statements, that's okay, like here. There was also part of this announcement was that we can now use switch as an expression, so I can type switch here and change this and change this. And if I want to return from here, I need to type yield, which is basically from this section of code, this is the result. And yes, this is, yeah. And for switch expressions, there is one important thing to note, or a few important things to note. One of them is that expressions need to provide value for every input, or needs to provide some result for every input. So for switch expressions, the cases must exhaust, in some sense that we will see later. The cases must exhaust the selector type. But in this case, like the selector type is some enum, which is like this enum, and I don't need this default here, because the compiler can verify that I have covered all the possible enum constants, and it will inject some default for me in case like a new enum constant will be added separately. But it's important to note that for all switch expressions, all possible values at the input must be covered. And it's called that it needs to be exhaustive. And to some degree, it also applies to switch statements, which we will see later. Then, since GTK16, we have records which are simple classes that hold data. The classes are immutable, so you cannot change the values of the components. You can create a new record instance with new values, but you cannot change the values. And this showing what is generated here. Some constructor equals hash code, and the accessors are not prefixed with anything. The accessors have the same name as the components. We also have seal types. I don't know if anyone used seal types here. Okay, good. So seal types permit us to restrict who can create subtypes of a type, basically. So I can say that all subtypes of node, or like the direct subtypes of node, can only be these listed here. And if I would remove this div node, the compiler will come and tell me, no, you cannot do this. And this is useful when designing API. You can say, I have this interface that is an API, and I only permit these subtypes to be created. Maybe I will show one more thing, and that is this. If you extend or implement a seal type, you need the thing that extends or implements a seal type must either be sealed or final or explicitly non-sealed, like this. Because at this point, like the literal node is no longer sealed, and anybody can extend literal node. But I cannot do it like this, like by accident. I need to say if I want the hierarchy to remain sealed or not, which I think is good because it prevents some accidents. And okay. And now I will switch to still language, but a huge topic of pattern matching. And I have an example that is similar to what we have seen with the seal types, and that is like known to me because it's ASTs. And imagine that you have some expressions, and you have a parser that creates an AST for the expression, which is an abstract syntax tree. And it can look like this. You have some operators, and the operators have some operands, like left and right operand, for example. And in this case, we have this plus, which is 1, and the other operand is the multiplication, which is 5 and 3. There are probably multiple ways to model this, but this is one way to model it. Here's some node that is like the most generic AST node, and then we have specific nodes for the specific operations. We have specific node for plus, for multiplication, for the literal values like 5 or 3. And now imagine you want to write a method that will take this AST node and evaluate it, and provide a value as if the expression was evaluated. So this is one way to write it. And this already uses pattern matching that was added in 16, so whoever uses 17 probably have seen this. And this basically means if n is an instance of at node, then please create a new variable called binding variable and assign the value from n into the newly created variable and cast stdiff. So basically this is the same as if I would write this and this and this. The meaning is the same, but note that I only repeated the type once, so less errors, more convenient, I think. some of you may ask, why not simply reinterpret n as at node here? So I think there are two reasons for that. One of them is that this is just one use of pattern matching, and this is called type test pattern because it tests the type of some value. But there, as you will see later, there are multiple other patterns possible. So this is just a small thing in a larger area. That is one reason, and the other reason, probably the more important, is if I write this run n and I have these two overloads of the run method here, and one takes node and one takes at node. And now there is a difference in if n is node, then I will call one, and if n is at node, I will call the other method, right? The type of n decides which method I will call. And for a very long time, Java was calling this method, right? And if we change the type of n to be at node, suddenly the other method would be selected silently. It would all still work, just another method would be called, which is, I think, another reason why it's why we are not reinterpreting the type as at node here, which of course does not mean that for other languages it's not a good option. It may be a good option for other languages. It's probably not a good option for Java to do it. And yeah, so this was pattern matching in Switch. It was in 16 and 17, so you may have seen it. I am on the back line. In GDK 29, we have also the same for switches. So I can write in the most brutal way. I can write it like this, which means basically the same. Like each of these cases is evaluated. This is a pattern. Now it's like pattern, like completely a pattern. And if the value of the selector matches the pattern, then the code here is executed. And as you see, it works for statements, of course. There are a few special things here. And let me first remove this default, and then let me remove this case. And now the compiler will tell me that the switch is not exhausted, that it doesn't cover all possible input values. These new switches must cover all input values. And in this case, node is a sealed type, so I don't really need the default. This is what I wanted to do. I don't need the default if I covered all the sealed subtypes of the selector type. And there is also a nice maybe some feature, and that is if there is case now I can return something, whatever I want. Okay, not like this. I need to do it like this. Because if I write it like this and node is now, it will throw a null pointer exception. If I write it like this and n is now, it will go through this option and will do whatever I want. It's like a simple nurture here, if I want it. If not, that's okay. And of course, I can use this as a switch expression. So like this, I will to change some code here. And this. And at least for me, this looks like concise, but I can still read it. I can still understand what is going on. It's just shorter for me. And yeah. So this is like, this was one step in the pattern matching journey. There was another step, and if you will look, yeah, let's start with this null node, for example. If I look at this multiplication node, I am not really interested in the mn variable, right? I'm interested only to know if the node is multiplication and about the operands, but not about the node as such. So there is a thing that is called the construction pattern, where I can do this, and the meaning basically is, if n is a null node, which means this, then please separate the null node, the instance, into its components, and then interpret this nested stuff as patterns and check if these patterns match the value that you deconstructed from the null node, right? And in this case, because the null node, you can have a look, these components are of type node, these patterns will always match any value that can be there and are called unconditional, which may become important if you start to dig into null handling, which we will probably skip here. You don't need to repeat these types, you can type var here, but that's just a relatively small thing. And I said these nested things are patterns, and the patterns can nest recursively. So what I can do is I can type this, and then I could do maybe this, for example. And it basically means still the same. If it's null node, take the first component, look at the first component. If it's literal node, then take the value from inside the literal node and put it in some variable called value. And now I can try to do some tricks here with this case. So I can put additional conditions on the cases. So I can type when, which is additional condition called guard. And I can type, for example, this, and say if it's 0 times something, then don't even compute the value of the right operand because it's useless. We know it will be 0. So this is this is a guard. This allows me to add additional condition on the case. And an important thing to note is that the evaluation of the cases basically goes from top to bottom, and I cannot. Some of these patterns are more general, or cases are more general than other cases, right? For example, if I see this pattern covers any null node in existence. If n is a null node, it will always match this pattern and always use this case. So if I would change this order like here, the compiler will tell me that this pattern is dominated, which is the formal word for it, by a preceding pattern. So, which basically means this case is useless because it would never be executed. So I cannot do it. The compiler will check for me. Yeah, and there is one thing that I forgot to mention when we were still in the if concept. So I will go back to the instance of inside ifs, which that is scoping for the binding variables. So if I type this, I can obviously use the binding variable here, and I think like quite understandably I cannot use the variable here, because the formal rule is that this variable is only declared if this expression is evaluated to true. So I can only use it in the two sections of the if, or I could use it here as well, of course. Like if I wanted to, I like this. And probably also quite understandably, I cannot use it here after the if, because I could get here like using both the true and false values. But if I, for example, return here, I no longer can get here using like the false section, right? I can only get here using the true section. So there is a special rule that the variable is, the scope of the variable is extended beyond the if. And it also works like similarly for loops. Which is good because I don't know, maybe I can check some preconditions. Like this, for example, I can check a precondition, finish early, and do something in the rest of the method. Of course, probably you don't want to write this, so it also works with the inverted condition. Because here, like, if n is instance of at node, then we will not take this branch. Right? I hope it's visible from this. And this allows like one to check some preconditions early and either throw or return some default value or something like this. I think this is a useful scoping feature. And it's there since the introduction of the pattern matching, for instance, in JDK 16. Now there are two more things on pattern matching that I would like to show you, and these are new things. One of them is in preview, and that is primitive patterns. And let's imagine that for some reason I have a very good way to multiply bytes in this example. Some very special way to multiply bytes. So these two apps for primitive types permit me to write things like this, and the meaning really is, if at runtime the actual value in the literal node, and let me go to the declaration of literal node, the value is an int, so it's definitely like much bigger than a byte. But if at runtime the value will fit into byte, then this will match. If the value will be 1000, this will not match. If the value will be, I don't know, 127, it will match because it fits into byte. So it's like a thing that allows me to check ranges to some degree at runtime. It also works in other contexts, but this is a useful context, I think. Yeah, and there is another thing that is currently under discussion, under design, I would say, for pattern matching, and these are pattern declarations or matcher declarations of the constructors. And let me imagine. Let me start with like a motivation for this. The nodes here are just nodes, but let's imagine I want to keep positions for these nodes. And I can go here and add some position. That's easy. The problem is that since I added a new component to a record, like the record got the new component also in the constructor, and also the like way the records are deconstructed have a new variable. So for constructors, yeah. So I can no longer like construct the node using the old way. This is just one parameter, right? But what I can do is to create a new compatibility constructor that will do, I don't know, for example, this. And now I can construct the node as before, because I provided some new constructor manually to to construct it. But when I have these deconstructors, I am in trouble now, because like the record has two components, but these patterns, there's only one pattern here, because this is some old code that I have now broken. And also another issue that is very very related to this is that right now this deconstruction only works for records. You cannot do it for your custom classes. So the solution for that is under design right now, so it will take some time and it may change, is to have something called deconstructors. I don't really want to show how it's implemented. And it basically, the idea is that I would declare something someday to say, and I can split this class into these components. And I could probably have more of these deconstructors. And it's basically a way to say, I know how to split this class or this record into these types of components that anyone can use basically after it. And with this new deconstructor, which is basically something similar to constructor, just in the opposite way. Constructor constructs an instance from values, and this takes the instance and creates some values out, or provides some values out. And with this, when this will be done, you should be able to first compatibly extend records, at least to some degree, and add the ability to deconstruct your own classes, which I think will be very useful. Okay. And there is one more, basically last language feature here, if you are okay with that. And that's, now it's called flexible constructor bodies. And it's not extremely common, but it happens, and when it happens, it's pretty bad. And that is, imagine I have like a constructor like this, and now I want to add a new constructor that would take some executable and some parameters like this. And now I, of course, want to call this constructor here, right? I want to create a list and call delegate to the existing constructor, ideally. But I cannot, before this flexible constructor bodies, I couldn't do this, right? I couldn't write this because this was an error. Okay, let me try to type this. This is what I would like to write, correct? And I of course forgot about this. But if I try to run this on, or compile this on 11 will tell me no, you cannot do this. Right here it will tell me no. You need to call you need to delegate to another constructor as the first thing in your constructor. But there is this preview feature now called flexible constructor bodies that allows you to put stuff before the super constructor call or before delegating to another constructor. It's actually only a Java thing or Java language thing, because you could do this in class files forever. Class files always supported this. So it's only about the language. And it's called flexible constructor bodies now because you can also assign to fields before calling the super constructor. Before it was just statements before super, and it just permitted this, but not this. But that's a detail. There was some progress in thinking in development of this feature. And now, okay. Now let's switch to a feature that everybody loves, and that is virtual threads. And I will show you the virtual threads in a way that I think they will not be used that much. I will show you how the frameworks will use it, not the users of the frameworks, I think at least. And let's start. I have this server, which is very slow to respond, but can handle very many input connections. It can handle many connections, but it takes the server to 100 milliseconds to respond to each of these requests. And then I have some code here that tries to read from the server some characters and print them. Yeah, and the server basically accepts an index and responds with a single character. So here I will like ask, give me character 0 and put it into an array. Give me character 1, put it in an array, and so on. And I can write it like this, very easy thing. The run is very easy. It just connects to a socket. It writes like the index that it wants to read, and it reads one character of output, one character of output. And I can run this. No, I can run it, but not like this. And it does what it should do. It just takes a lot of time, right? And the program is not doing anything, basically. All the time it's waiting for the response, right? So can I do better? Okay, I can. And let's call it background. And I can use, for example, some executor service, like here, and now it's called submit here, and I can write it like this, which will like use threads to use as many threads as needed to run the tasks separately. So I will basically start many connections to the server and then like fill the output or use the output, right? And this will work if I will run it. It runs, and it runs faster. It doesn't wait so long, which is good. But now let's say I want to read 55 characters from the server, and no, I cannot, because I ran out of memory basically. In this case, I intentionally ran the code with very small ulimit to run out of memory very soon. But the number of threads here, this allocates like real operating system threads, and these are really heavyweight, and you cannot allocate millions of them. You probably cannot allocate even tens of thousands of them, on at least not on a machine like this. So if something wants to use very many threads, it's like difficult to do it using the operating system threads, which allocate a lot of memory and are very slow to start. So what virtual threads are is basically a lightweight thread that, if it can run, it will be put on some real thread from the operating system. It will run, then it will block, it will be put on heap with just some minimal snapshot, and some other virtual thread will be run on the thread using the thread, and when like the conditions for the thread that is stashed aside will be met to be runnable again, it will be put at some point into some platform thread and run. And so if I run this, it will work. Hopefully it will work fast, and it can work. It can scale much better. And let's see, if I put 111 characters here, it will still work. But there is still one problem, and yeah, and this was in JK 21 as final. In JK 24, I believe that even this should work even for synchronized, so that if the virtual thread is synchronizing, it still can be stashed away, which didn't work before. It was pinning that the synchronized blocked the platform thread. So I believe this is fixed in 24 right now. But there is another issue if I write it like this, and that is, imagine that I break the server, and the server will now refuse to answer for positions that are above 100. It will just close the socket and stop responding. And if I have written like this, I will get some weird output here, which is certainly not correct. It was nicely typed hello world here. The problem is that this throws an exception. The exception goes to some logger, and because I don't have loggers configured, it goes basically to death now. And even if I had loggers configured, it would log somewhere. And that's probably what I want. I want here to find out that something went wrong, not in some logger. So one of the possible solutions, and that's in preview right now, is structured concurrency, but not like this, not like this. I could say, please start for me some scope that I expect everything will pass, basically. And I can put stuff into here, and after that I can say I want to wait until all the tasks are done, and if there was any error, please throw an exception. And now this works in a way that if any of these tasks throw an exception, the exception will be return here, and I think it will not even schedule new tasks if there would be any schedule. If one task fails, it will not schedule new tasks for me anymore. And if I run this, I will get some exception, which is what I wanted. I want to know that something is broken, not just some data. And of course, I could handle it with the executor service, but I would need to handle it's not completable future, it's just a future. I would need to handle the futures there, which is complex. This is, I think, much easier to handle. And there is one more very new feature that is, there is a yet draft for it, and it's also like under design, it's being worked on, and that is stable values. And let me show what it does on this example. And the example is singleton. And let's say I have some class for which I want only one instance to exist, but I want to initialize this instance later. So if I do it and for now, let's say I want to do it in a single thread, from a single thread only. So I can do it like this, just if the instance is null, create a new instance and return the new instance of the existing instance. And if I run this, it takes, I don't know, 300 milliseconds. Good. Yeah, okay, sorry. I have a test here that calls the get instance about 1 billion times and calls a method on it, on the result. Now, I probably don't want singletons to work from a single thread. Right? That doesn't make much sense. So what I can do double check locking. Like I don't like this pattern, but I believe this is the correct pattern to do double check locking. The field is volatile. There is limited number of reads from it, and so on. So you could use double check locking like this. I suggest no, but it's possible. But like now it's much slower, right? It takes 1.5 seconds now to run, and the test is the same, and the test still uses single thread. It's because like the volatile here is a read barrier, so it needs to synchronize memory, and it's complex for the hotspot to do something with the code. There is another pattern right now that I can do, and that is the holder pattern. I can create a class which will have a field, and the field will be initialized in a static initializer, and then the field will be initialized when I use this class, and I will use this class only in this getInstance method. So this way, basically, this field will be like created, and the value will be assigned only when needed, only when the getInstance method is called for the first time. Okay, this works. This works very well, because there is this is very well optimized, I think. The problem is that you actually need to type the class somewhere, or maybe generate it at runtime. It's relatively complex to do this. You actually need to have a class that will be loaded by the class holder using the proper lock that will initialize the value. So at the end, and the important thing is that in hotspot, there is a special annotation called stable, which basically says this field, or something like this, will be initialized at most once during a run of a VM. And hotspot knows that it can optimize. If someone assigned to the field a value, hotspot can optimize very heavily on the value, because it knows the value will not change. The problem is that you cannot use this annotation outside of Java base. Let's say it's not completely exact, but outside of very core Java, you cannot use this annotation. Hotspot will not test it, even if you put it there somehow. But the idea is that maybe there is a way to basically wrap the functionality in a safe way, using some library, to provide the same benefits safely. And this is stable value. And here, this is like very simple way. I say here stable value of supplier, and it takes a supplier and returns a supplier. And it works in a way that if I call the get method on the supplier that was returned, for the first time, it will call this and cache the value forever, basically. That's it. I think this is very nice. And the performance is basically the same as for the holder pattern and the single thread case. So this is very nice, and there are also other factories. So basically, this is a factory for arrays, like arrays, where you can initialize like individual entries or positions in the array if lazily and so on. So I think I hope this can be made, and that it will be very nice. Okay. And there are two more things that I would like to show you quickly. And I don't know. Okay, a question. Who knows about JShell here? Okay, so let me show you JShell. So JShell is read-aloud print loop for Java. It's a tool. It was in JDK 9, so it doesn't actually fit to what I said from JDK 10 onwards, but it was in JDK 9. I learned that many people don't know about it. And it allows you to print, it allows you to type and evaluate some snippets, which can be expressions or statements or declarations like methods or classes, and fields, but fields are basically also statements, right? Or variables are also statements. So I can type 1 + 1, it will say 2. I can type integer to hex string 123, and it will print something. I personally use it to like experiment with some APIs if if I want to experiment with APIs, I use it. If I want to quickly know some answer to some real question, I even use it as a calculator personally. But I am one of the people working on it, so I may not be a good sample. And yeah, as I was saying that you can declare methods here. So I can do this. No. I can declare methods here and call them if I want, for example. But I think like the experimentation with new APIs is like that's one of very strong points of JShell. And okay, of course I don't recall where I had the presentation, and I will tell you one more thing, and that is that we as in Oracle have an extension called Java for VS Code that provides language support for Java inside Visual Studio Code, obviously. It's based on Apache NetBeans. It's based on Java C, and it has a feature that you can, it brings some version of Java C with itself, but it has a feature that you can disable the bundled Java C and use Java C from the JDK. So you can, to some degree, see new language features. If you have JDK with new language features, it can be used with this extension to see how these new features work. And yeah, let me show you. It's this extension basically. And yeah, that's it from me right now. And I don't know if you have some questions, or if there is something you would like me to talk about. Okay.
So one thing that I still miss in Java from time to time, I programmed in Kotlin, for example, and it has limited support for operator overloading. I know it's a dangerous thing if untamed, but I believe having a limited support for it, for example, for collections, makes the code much cleaner. Then you can access maps or lists with index. What's your take on this? Will it ever be in Java, or is it total no-no?
Okay, operator overloading. I am not sure if it's total no-no, but I don't think it will be there anytime soon, and maybe never, quite probably never, but I don't know. Definitely, I'm not aware about any plan.
I have a question to the pattern matching. There was an example with A and N, and it looked like the N was available after the
Yes.
after the if statement.
Yes.
That's intentional, or I just didn't see any error under?
No, you mean this?
Yes, I mean this.
Yes. In this case, if okay, let me flip the if in the opposite way. If N is not an at node, it will go to the else section, and the else section cannot finish normally. It will always throw. So we can get here only if this was true. So there is a special statement and very intentional feature in the language that extends the scope of this variable after the if. So that
And without the else branch, it wouldn't be extended, or
yes, if
you remove the else branch, then there will be syntax error. Okay, I see.
Yeah. Because if you write like this, you can get here using like both true and false on the instance of right. If there is no throws.
Yeah, I just didn't see the exceptions. So it was very strange for me that it's possible to continue after the instance of I expected it could be only inside the if statement or inside the element which is creating the N variable or handler of the variable.
Yeah. Okay. Yeah, but this is very intentional.
Okay.
Okay.
Could you show the implementation of the deconstructor?
I guess I will show you, but it can change. It will probably change, so don't. It's some prototype. These are the output values, and this is some statement that says, and these are the real values that should be written. But yeah, don't put too much on this. It may change. I think it will change, at least to some degree. So yeah, it's just some prototype. And of course, like even after this previews, it still may change. So
in this case, couldn't you use underscore like don't need to deconstruct, but use the underscore. It was featured in 21, I think.
Yes. Sorry, yes, I forgot to mention it. Yeah, like in this case, right? This is the one.
Yeah.
I don't need this value, so I can use underscore, and it's like a more general feature, so that you can have like classes with variables without names, like this. And the like this actually took some time to do, because underscore was a valid identifier in GK8, so it was taken out of valid identifiers in 9, and then so there was some progress in this one. Yeah, that's a nice feature. It's not that much useful for local variables, but you can use it in like for me. I guess no, if I have map from something to list, and then and I need to name it, and I do compute with absent, then like no, not here. So there is yeah, here, and this no, I cannot type. Like here, the lambda basically takes a parameter which is the key, and in this case, I am usually not interested, or often not interested in the key. So this is the underscore can be used as a unnamed parameter to lambda, for example, in cases like this. And for patterns, it's called unnamed pattern. It matches anything and doesn't produce any bindings. Yeah, and yeah, you had a question.
My question is also related to the constructors and the constructing patterns. Like, quite often I find it useful if I have a record to deconstruct it directly to its fields. Like if the record has 3 fields, I ideally want to have one line assignment that creates 3 variables, one for each part of the pattern. I can see with switch in cases we can do it, but can it be done with a single line var assignment, or will this ever be supported? Or for example, to destruct a list into its first 3 components using this pattern, which is also possible in Kotlin, for example.
Right now, no. Eventually, probably yes.
I think this
but
is
it
a
will,
feature.
Like it's. I think it has multiple names. It's like, I think one of them is match statement. Basically, it allows you to deconstruct into, like you using assign basically. Yeah. It's. I believe it's somewhere in the pipeline. I don't know.
It's already there. The work is in the progress, but no deadline.
Yeah, you can say it like this. Yeah.
questions?
I have a question regarding this. So this is possible on records only, right?
Right now, yes.
So for example, optional is a class,
Yes.
and we can use it. It's optional.
Yes. Right now, on
Is there
records.
any plan to make this somehow possible? Like maybe migrate optional to class to record or?
I don't think it would make sense to change optional to record, but there is, I believe there is definitely, I don't know if I want to say plan, but the idea is that the pattern should work for optional eventually. It's just not designed and done yet. But eventually, I believe the intent is to do it. Yeah,
Thank you.
I guess.
Thank you, Jan, for the interesting talk. Please help yourself A321 at the end of the hall. There is food, there is beer. Let's talk. Thank you very much.
Thank you.
You know,